SCON register, we can call it as a serial control register. Here SCON register is an 8-bit register. I think you are observing here RI, TI, RB8, TB8, REN, SM2, SM1, SM0. Okay, we'll discuss what exactly these codes we'll discuss later. Okay, totally we have from LSB 0 to MSB 8, 0 to 7. It's a 8. It indicates that it's a 8-bit register used to program the start bit, stop bit, and data bits. What we are going to data will be framing, among other things. Okay, what we are going to transmit with respect to this serial control register with respect to start and stop bit, we are going to use to transmit the data. Okay, here what are the different bits with respect to this is with respect to 0, that is serial control dot 0, serial control dot 1, 2, 3, so on up to 7. We have totally 8 bits. Okay, initially first one will be your RI, that is receive interrupt flag. It will be going to set by halfway through the stop bit in the mode 1. When we are going to use mode 1 programming, we are going to deal with this SCON.0, that is your receive interrupt. When we are going to deal with the transmit interrupt, this is also which will be going to clear the switch. What we are going to connect with respect to the external device, we are going to clear the data. Okay, with respect to SCON.2 and SCON.3, that is RB8 and TB8, we are not going to use here. Okay, in the future purpose, they are going to keep this. And for this serial control, dot 4, 5, 6, 7, it will be, first one will be REN, that is set or clear by the software to enable or disable the receiving the data. And the fifth one will be used for multiprocessor communication. SM2 and SM1, SM0 will be going to select the serial mode. Either it may be mode 0, mode 1, mode 2, mode 3. How we are going to select in the timers, timer 0, timer 0, timer 0, timer 1, timer 2, timer 3. Like that here we are going to use the modes of serial communication. Okay, that we can discuss one by one. You can make a note of this, please. Make a note of this. Okay, we'll move to next slide.
2 minutes, sir.
See, always we are going to use SM2, TB8 and RB8 will be 0. Make 0 of these three. Why? Because these two are used for widely used for future purpose. Not we are not using right now, so that we have to make 0 0. And SM2 will be used for the multiprocessor communication. This is also make it 0. Okay, then we'll come to the next. We'll discuss one by one. Next year we are going to discuss first SM0 and SM1. What exactly SM0 and SM1? SM0 and SM1 are D7 and D6 bit of a SCON register respectively. Here we have a 2 bits determined for the framing of a data by specifying the number of bits per character. What we are going to transmit a data, we are going to decide which mode we are going to select. Based on the SM0 and SM1, we are going to select the modes. Here we are going to use start and stop bits also. Then we are going to take the following combinations based on that SM0, SM1, 0, 0, 0, 1, 1, 0. Okay, if it is 0, 0, if it is 0, 0, I'm going to select a serial mode 0, serial mode 0. If it is 0, 1, I'm going to select the serial mode 1. It will be 8-bit data transfer with respect to one start and one stop bit. Okay, we need to identify our data. We are going to use, or we are going to separate our data with respect to start and stop bit. Okay, when we are going to transmit a data, we need to give one start bit, and when we are going to end with our data, we are going to give it as a stop bit. In between the data, we need to represent these 2 points. Okay, major we are going to use serial communication mode 1 programming we are going to use. That is why we are going to specify that 1 bit will be stop bit and 1 bit will be start bit, that we are going to consider. Then if I am going to take SM0 and SM1 will be 10, it will be going to select the serial mode 2, and if it is 11, it will be going to select serial mode 3. Okay, that is the four serial modes. We are going to use only mode 1 is for right now we are going to use only mode 1. Okay, further explanation we are going to deal with these 3 modes. Later we are going to discuss about all other modes. Already we are going to use SCON register with respect to the serial mode 1. We are going to choose serial mode 1 by make use of SM0 will be 0 and SM1 will be 1. And in this, especially we are going to transmit a data. When we are going to transmit, need to transmit a data, we are going to use start and stop bits. Okay, it will be compatible with the communication port of your IBM PC. What we are going to transmit with respect to the hyperterminal connection through we are going to transmit a data. It will be going to allow the baud rate of a variable, and it is set by the timer 1 of your 8051. Baud rate will be decided with respect to the data what we are going to give a number, what we are going to load the number. Based on that, it will be going to decide the baud rate of the particular program. And next will be, okay, frequently make a note of all these things. Okay, SM0 and SM1 will be over. Next SM2. This enables the multiprocessing capability of your 8051. We are not using it. That is why we are going to make it as SM2 is equal to 0. Okay, this is a 5th bit of your SCON register. It will be enable the multiprocessing capability of 8051, and it will be beyond the discussion of this chapter. We are not going to use this much. That is why we are going to make it as a 0. SM2 will be make it always it is a 0. Next will be REN, receive enable of your D4 data bit 4 of your SCON register. Okay, shall I move?
Yes, sir.
Okay. Next take receive enable. The receive enable bit is the 4th bit of your SCON register. The receive enable bit is also referred to as a SCON.4. We can also represent it as a SCON.4. Since SCON is a bit addressable register, we are going to use receive enable bit is high. Always we are going to make it as a receive enable bit. REN bit will be high. Always we are going to give it as a logic 1. It will be allowing the 8051 to receive the data on receiving data pin. Whatever we have in the 8051 receiving data pin, that pin it will be going to accept the data from the outside. It will be going to receive the data. That is the meaning of receive enable. Receive enable. Receive pin, if I am going to enable, means I am going to give it as a logic 1 of this particular bit. It will be going to allow the data, it will be going to allow 8051 to receive the data on the receiving data pin of your 8051. Okay, with respect to that 8051 of both transmitting and receiving data, receive enable must be set to 1 by making Rn is equal to 0. If I REN making a 0, the receiver is disabled. If I am going to make REN is equal to 0, I am not going to receive any data. If I am going to make it as a 1, then only I am going to receive the data. If I am going to keep REN is equal to 1 or REN is equal to 0, we can be achieved by the instruction. We are going to set one instruction equivalent of the say, instruction set bit SCON dot point 4. What we discussed in the timers. Okay, tmod set bit like that. Here also we are going to set bit SCON dot point 4. If I am going to take set bit SCON dot point 4, it will be going to take it as a, it will be going to receive the data, so that it will be logic 1. If I am going to stop the receiving data, I need to give a instruction that is clear SCON dot point 4, CLR SCON dot point 4 if I am going to give, so that the receive enabled data is equal to 0. The meaning of that, it will be 0. It will be going to stop the receiving the data. Okay, that is the meaning of your receive enabled data. Like that, if I am going to use transmit interrupt, that will be 805 finishes the transfer of 8-bit character. Okay, it will be raises the transfer interrupt flag to indicate that it will be going to ready to transfer the another byte. Okay, for example, if I am going to transmit a data now serially, I am going to transmit. Now what I am going to transmit a serial data, that is yes, YES I need to transmit. Okay, YES it will be having a three bits, 3 digits I have, or 3 alphabets I have. I am going to transmit YES. That will be a equivalent of hexadecimal value. I am going to differentiate separately. I am going to transmit that. After that, it will be going to give a transfer interrupt. If I am going to give, it will be going to ready to the another byte. Okay, if I am not giving instruction with respect to transmit interrupt, it will not be going to take the another data. Okay, another data, my another data will be bit. Okay, I need to transmit bit, bit alphabets I need to transmit. I need to give transmit interrupt. Okay, interrupt. Again, it will be going to take the another data. That is the meaning of this. Okay, if TI transmit interrupt bit is D1 of the SCON register, and this is extremely important flag bit of 80 SCON register of 8051. When 8051 finishes the transfer of a 8-bit character, means first I am going to transmit a character of yes. Okay, after completing that, it will be going to raise a flag. Okay, it will be indicate that it will be going to ready for the transferring another byte of a data. That is the meaning of your transmit interrupt. The transmit interrupt bit is raised at the beginning of the stop bit. It will be going to for the transmitted data. It will be going to discuss with respect to the program, how exactly it will be going to work. Next, we have a receive interrupt. Receive interrupt will be D0 bit of your SCON register. It will be going, this is the another extremely important flag bit of your SCON register. When we are going to transmit 8051, receives the data serially via receiving data pin. It will be gets right to the start and stop bits of a. It will be going to place the byte in the SBUF register. It will be going to use in the SBUF register. It will be going to raise the RI flag, that is receive interrupt flag. It will be going to raise. Based on that, it will be going to transmit, and it will be going to receive the data. Please make a note of this. Next, we will discuss the programming of 8051 to transfer data serially. Or
2 minutes, sir.
or
Yes, sir.
okay, make a note of this. Programming the 8051 to transfer data serially. These are the steps we need to follow here. First one, T mode register is loaded with a value 20H. It is not mandatory to load 20H, whichever the value you want you can load, but we are going to use a frequent number, same in the timers, like that only in the serial mode also we are going to use this number only. That is why we are going to load it with the 20H, indicating that it will be uses timer 1 in mode 2 8-bit auto reloaded. That is the intention to use this 20H. If I am going to use 20H, it will be going to use timer 1, and in the mode 2 will be 8-bit auto reloaded option. It will be going to set for the baud rate. Okay. For the second, in the second step, we are going to load the TH1 is loaded with one of the value, any number you can take. So, when we are going to deal with the program, table 10.4. Okay, whichever the number, either -3, -6, -12, -24, any number you can select. Based on that, it will be going to set the baud rate. Okay, based on that, we are going to load the number for the serial data transfer. Okay, that is assuming the frequency will be 11.0592. Why? Because we are going to use IBM PC. That is the standard frequency we are going to use of your crystal frequency. Then coming to the next point, the serial control register is loaded with the value of 50H, indicating that it's a serial mode 1, where an 8-bit data is framed with a started stop bits. Okay, we are going to use for mode 1, that is why we are going to load it with a 50H, 50H. This 50H will be loaded in the serial control register. Okay, SCON register what you have, 5 is equivalent of 0, 1, 1, 0, and rest of the 4 bits will be 0, 0, 0, 0. Based on that, it will be going to select the serial mode 1. Okay. Next point, if I am going to load TR1 is set to 1, it will be going to start the timer 1. TI is cleared by the clear TI. What is TI? Transmit interrupt. What we discussed in the last slide, that is transmit interrupt. Initially, we need to clear the transmit interrupt. Why? Because, for example, previously, if I am going to transmit some of the serial data, that will be loaded in the transmit interrupt. That is why first we need to clear the old data. Okay, then we are going next step in the character byte to be transferred serially with respect to the SBUF register. And next will be the TI flag is bit is monitored with the use of instruction. A jump if no bit of your transmitting bit, it will be compared with some of the numbers. That is why I have taken XX. It will be going to see the character has been transferred completely or not. It will be going to check. To transfer the next character, again we are going to start with a fifth step. Again we are going to clear the transmit interrupt. Again we are going to load some other data. Again we are going to transmit. This will be keep on repeating. Okay, these are the steps we are going to follow for the programming of 8051 to transfer a data serially. Make a note of these points, and next we have to analyze one program. I will give one program. You have to analyze that. Whatever the steps here I have written, by make use of these steps only, you are going to write the program. If you know, this is like your algorithm. Over okay, take next program, a simple program. Write a program for the 8051 to transfer letter A serially at 4800 baud rate continuously. Okay, trace this program. 4800 means we need to take a decimal of -6. Value TH1 will be -6. We are going to take hexadecimal equivalent. FA is a hexadecimal. In the another table I had given the values. Okay, observe here. Okay, see here. Move T mod comma as 20H. Why? Because we need to select a timer 1 mode to auto reloaded. Auto reloaded, why we are going to use? After transmitting this, automatically it will be going to reload. That is the intention we are going to use auto reloading. Move TH1 comma as -6. It will be indicates that your baud rate. That baud rate is suitable for to transmit your data with respect to your 8051 microcontroller and IBM PC compatible. Then move SCON comma hash 50H. We are going to serial control register loaded with a 01100000. Then it will be going to start 8-bit, one stop bit, receive enable. It will be going to enable. Set bit TR1. TR1 will be going to set. Why? Because we need to start to transmit the data. That is why we are going to set bit first. Start the timer 1. Move sbuff comma hash a. Serial buffer we are going to load a letter A. Why? Because we are going to transmit a letter A serially. That is why we are going to load that particular letter to your serial buffer. Jump if no bit TI here. It will be keep on taking the loop. Then it will be clear TI. Yes jump again. Again it will be going to transmit A. Loaded A. Again it will be keep on transmitting A. When we are going to stop program, until we are going to stop the program, it will be keep on transferring continuously. Why? Because I did end the program. Why? Because here the question is transfer letter A serially at 4800 baud rate continuously. Means continuously we need to transfer. That is why we are not going to end the program. Okay, if I want to transmit a serial data of YES or NO or bit or baud, any serial data with respect to 5 or 6 letters or NTN, my initial I need to transfer. Okay, I can take this, I can end the program. After NTN, what next? We need to end the program. If I am not going to end the program, it will be keep on transferring the data serially. That is the meaning. Make a note of this program and these comments. Next program you have to analyze. Take one homework program. Try this. Kelisaya?
Yes, sir.
Make a note of this program. Write a program to transfer a letter Y serially at 9600 baud rate continuously. 9600 baud rate continuously, and also send a letter N through port 0 which is connected to display device. Try this program. I will explain the concept. Here, what we discussed now, first program, same only, but I have given a letter Y and I have changed the baud rate. You have to change the value of -6 is replaced by -3. Why? Because 9600. Then after transmitting serial data, again one more question I have added with this same. I need to transfer letter N through the port 0. One of the port you select and you transmit that port 0 and it needs to be displayed. Okay. Port 3.1 it will be going to transmit a data. Then port 0 it will be going to some letter N to display. Like that you have to write a program. Okay. Next, this program, second program. Write a program for the 8051 to transfer bit serially at 9600 about 8-bit data, one stop bit. Do this continuously. Trace this program. 9600 indicates that it's a -3. Mode 1 programming, that is why 50 I have taken. Again, T mod is equal to 20. The first start the timer. I'm going to move A comma B. Means I'm going to take the accumulator. I'm going to store the letter B. A call transfer. A call transfer. First I need to transfer A. Again move A comma I. Again A call transfer. I need to move S buff. Accumulator alliradana. I'm going to copy to S buff and jump if no bit in transfer interrupt. It will not be stop. It will be clear TA. Again it will be going to return to next. Again it will be going to load. See, first step, A call transfer, if I am going to take, it will be coming over here. After return, after A call, it will be going to move A comma I. After A call, it will be coming here. After A call, it will return, it will be going to take next bit. Like that, it will be going to keep on transferring the serially data. If you want to transmit a data, NTN also. Replace BIT in place of BIT, you can transmit NTN or whichever the data you want, you can transmit. You can check all these things in your lab. Interfacing, display device you are going to use, LCD display. You can write a program and you can transmit a data. Or else you can try for your name or your subject name. Micro, MICRO, you can transmit the data serially. Anything you can try.
Sir, after S jump again only we can stop the program now, sir.
Sorry?
After S jump again only we can stop the program now, sir.
After a S jump, you can end the program. If you want, you can end. Why? Because it's a serial data. Serially, we are going to transmit. Do this continuously. That is why we have not given end. If you want to end, only once you transmit and you stop the program, you can give end. After S jump, you can give end. Okay, in the next class, we'll discuss importance of TI flag, importance of programming of 8051 to receive data serially. We can discuss in the next class. You can make a note of this and you can exit.